Can you hear me?
Yes, sir.
Actually, there was a small internet connectivity issue here, but I think it was resolved now. Yes. Yes. Now, straight question to my students, those who have joined. What is the Newton's law of cooling definition? Can anyone answer? At least the definition. What is the statement of Newton's law of cooling? Okay. So the Newton's law of cooling states that the rate of change of temperature of an object is directly proportional to the difference between the temperature of a body and its surroundings. This is the Newton's law of cooling. So which is having many applications in science and engineering. Okay. And these are some crucial points regarding this Newton's law of cooling. The first one is, if you see, an object's temperature over time will approach the temperature of its surroundings. Okay, this is very important. When the object is cooling, when it is coming under, when the temperature of the object is decreasing at certain time, and after certain time, suddenly the temperature of the object will reach the room temperature or the surrounding temperature. And one more thing, the greater the difference between the object's temperature and the temperature of its surroundings, the greater the rate of change of the object's temperature. And the most important thing is, this change is a form of exponential decay. And this change is proportional to the exponential decay here. That is why when we are formulating the equation by differentiating the problem, here we are going to take the logarithm. Here the logarithms are two types. One is logarithm base 10 and one more logarithm base e. Logarithm base 10 is called the common logarithm and the logarithm base e is called the natural logarithm. So we use the natural logarithm because here, according to the third point, when the rate of change or the change in the temperature is following the exponential decay. Can you hear me?
Yes, sir.
Right. Okay. Yeah. If you see some real life applications, yeah, to predict how long it takes for a hot cup of tea to cool down to a certain temperature. Yes, this is one application of the Newton's law of cooling. And by coming to the second, to find the temperature of a soda placed in a refrigerator by a certain amount of time. Okay. In crime scenes, Newton's law of cooling can indicate the time of death given the probable body temperature at time of death and the current body temperature. Okay. Dear all, as you know that, I think you have heard about this forensic science. The people who watch the movies also, yeah, when there is a crime, when there is a murder, or when there is a suicide, obviously the police department or the CBI or CID people are going to start the investigation. But before they start the investigation, the forensic science people will come. They're going to collect some evidences. They're going to collect some clues here at that surroundings. Okay, where there is a dead body near in the premises of a dead body, they're going to collect some samples. The samples may be blood samples or fingerprints, thumb impressions, footprints, or hair samples. They're going to collect all the samples. People know the forensic science people are going to collect, yes, these samples. But one more thing is there. Not only they're going to collect the samples, at the same time, they are going to give the time of death. That is very important here. They will collect the samples of blood, DNA, as well as fingerprints, but at the same time, they are going to estimate the time of death. How it is possible? See here, dear students, normally our temperature is 98.4 degree Fahrenheit, usual temperature. But once we die, the temperature of a body will reduce. Once a human being will die, the temperature of a body will reduce. So based on this point, here they're going to apply the Newton's law of cooling because the temperature of a body is reducing. So they apply the Newton's law of cooling. They clearly give you, and clearly means they'll give you an approximate time of death. But that is very crucial. Okay, now for the people who are going to investigate this crime, along with the blood sample, fingerprints, okay, the time of death is also crucial. But to determine the time of death, they use the present concept, yes, Newton's law of cooling. So that is why this third point I collected. In crime scenes, Newton's law of cooling can indicate the time of death, given the probable body temperature at the time of death and the current body temperature. So when the forensic science people are starting investigation, they are going to collect 2-3 samples from the dead body. That means the temperature samples, and clearly they apply the Newton's law of cooling, and they give you the time of death. This become a probable lead to the investigation people. And whether they may be CBI or CID, this is going to be a crucial lead. This is one of the important application. Okay. Now see here, I have collected a problem here. See, the pizza heated to a temperature. Actually, initially we have a pizza at some temperature, and normally most of the people are interested to know the applications. So that is why I'm starting with the application problem only here. If the pizza cools from 450 to 370 degrees in 1 minute, how much longer will it take for its temperature to decrease it to 120? Yes, this is one problem. Okay, now this can be solved by using the Newton's law of cooling. Okay, now, yes. Dear all, now I'm going to explain the concept along with the problems. Yes. Let us consider an object and denote the temperature of an object by theta. Yes. Okay. Here we have an object. Let us denote the temperature of an object by theta, and these are the surroundings of the object. Yes. And let us denote the temperature of the surroundings by theta naught. Yes. Let us denote the temperature of an object by theta and the temperature of the surroundings by theta naught. Yes, I'm starting investigating on this object. Okay. And here, dear all, the temperature of an object is decreasing. Assume here the temperature of an object is decreasing. Initially, I have collected a sample. Initially, I have taken the temperature of a, yes, assume that may be some 85 degrees centigrade. After 10 minutes, have taken another reading. It reduces to some 72 degrees. And after 20 minutes, I took another reading, some 61 degrees centigrade. After 30 minutes, I took one more reading. Maybe it is 45 degrees centigrade. For every 10 minutes, I have collected some readings from this object. Here, dear all, the temperature of an object is decreasing. Okay. Obviously, the temperature of an object is decreasing. Now, the question is, what is the temperature of an object after 23 minutes? This 23 is not available in this table, but we have the information at 0, 10, 20, and 30 only. But here I'm expecting the temperature after 23 minutes. Or at what time the temperature reaches 30 degrees. In the first question, I'm expecting the temperature after a certain time. But whereas in the second question, I'm expecting the time after certain temperature. Yes, these are very easy to answer. But if you want to answer these two questions, we have to understand the present concept, Newton's law of cooling. If you want to answer such type of questions, what's the temperature of an object after certain time, or at what time the temperature reaches to certain degrees? If you want to answer these questions, okay, now you are going to study, or we are going to depend on Newton's law of cooling. According to Newton's law of cooling, the rate of change of temperature of an object, the rate of change of temperature of an object is directly proportional to the difference between the temperature of an object and their surroundings. The rate of change of temperature of an object is directly proportional to the difference between the temperature of an object and its surroundings. Here, I already explained the temperature of an object is theta. The temperature of the surroundings is denoted by theta naught. If you are going to formulate this, when we are going to formulate this, many people, I think many people are listening this class. Can anyone answer what is the rate of change means? How to represent this in terms of a derivative? May I know? Anyone? If you answer, then only I can understand you are following. And the session is going to be very interactive way. Can you hear me at least? Can you hear me? Ma'am, can you hear me?
Sir, you are audible and clear.
Sir, I'm
Sir,
expecting some questions from
Lakshmi madam,
answers from the students, but
Sir,
nobody is
students.
responding.
సార్ ఇప్పుడే మ్యూట్ ఆప్షన్ అయింది సార్, దానికి అవ్వట్లేదు, ఇందాక నుంచి ట్రై చేస్తాను.
ఓకే అండి, చేశారండి. ఒకసారి హాస్టల్లో కూడా స్టూడెంట్స్ అటెండ్ అవుతున్నారు, గర్ల్స్ హాస్టల్లో. వాళ్ళని కూడా సార్ అన్మ్యూట్ చేసి ఇంటరాక్ట్ అవ్వమని చెప్పండి.
ఓకే సార్. సార్ అనిల్ సార్, మీరు బోర్డు రాస్తున్నారా సార్? మీరు అది విజిబుల్ అవ్వట్లేదు సార్. మీరు ఓన్లీ స్క్రీన్ షేర్ చేశారు కదా సార్ ఇందాక, పిక్ అది ఒకటే వస్తుంది సార్.
చేశాను మేడం. ఓకే,
అది అవ్వట్లేదు సార్, చూడండి సార్. అంటే మీరు ఇందాక నుంచి ఎక్స్ప్లెయిన్ చేస్తున్నారు కానీ
రాస్తున్నాను మేడం నేను ఇక్కడ.
అది రావట్లేదు సార్ ఇక్కడ ప్రెజెంట్. మామూలు ప్రీవియస్ గా మీరు ఏదైతే ప్రెజెంట్ చేశారో అది ప్రాబ్లం ఇచ్చారు కదా సార్, ప్రాబ్లం స్టేట్మెంట్, అది ఒకటే వస్తుంది సార్.
ఇది ఇంతవరకు వచ్చిందా మేడం?
ఎస్ సార్, అక్కడ వరకు వచ్చింది సార్.
ఓకే మ్యామ్, ఐఎమ్ గోయింగ్ టు రిపీట్ దిస్.
మీరు ఏదైతే స్టార్ట్ చేశారో అది రావట్లేదు సార్
ఇది
ఇందాక.
రాలేదు. ఇప్పుడు మేడం, ఇప్పుడు
ఇంకా లేదు సార్, రావట్లేదు సార్.
నా
లేదు సార్, అదే స్ట్రక్ అయ్యి ఉంది సార్, అలా ఇట్లానే ఉంది.
madam, shall I reconnect this once again?
ఎస్ సార్. ఎస్ సార్. సార్ అనిల్ సార్ వస్తుంది సార్, బోర్డు వస్తుంది.
Mute. Now, ma'am, both are okay.
ఓకే సార్, బోర్డు.
Okay, ma'am. Voice is also clear now.
ఎస్ సార్, ఎస్ సార్.
Ma'am, if there is any
Continue.
discrepancy, please inform immediately, ma'am. Okay.
ఓకే, ఓకే సార్, ఓకే సార్.
Right.
కంటిన్యూ సార్, ప్లీజ్ కంటిన్యూ సార్.
Okay, ma'am. So as a motivation to the concept, initially I presented some slides and I was explained where this concept was utilized. Now I'm going to enter into the concept. I mean, how we are going to formulate to a differential equations and how we are going to apply the formula to the given problems to find the temperature and objects. Okay. Right. Okay. Let us consider an object and denote the temperature of an object by theta. Let the temperature of an object. Here we have an object and let us denote the temperature of an object by theta. And these are the surroundings. And let us denote the surrounding temperature by theta naught. Okay. And the most important thing is here the temperature of an object is a decrease. Let us assume the temperature of an object is decreasing. Okay, here I am doing some small experiment. I am collecting some samples from this object. Here the temperature of an object is decreasing. Initially, at the beginning, I have collected one sample here. I have taken one reading from the object and I found, yes, it is 65 degrees centigrade. After 10 minutes, I have taken another reading. Somebody is going to write something. All of you, please don't disturb the class. Please behave in a matured way. If you interrupt, it is not possible to write. Dear students, please, can you please remove the lines? Ma'am,
ఎస్ సార్.
somebody is going to write something. Is going to a few fellows are going to disturb the session.
సార్ ఓకే సార్, చూస్తాను సార్ అవి.
Dear all, we are here to transform the knowledge what I have, not to punish or not to scold anyone. If you are not interested, you may leave, but don't disturb the class. Okay. So after the 10 minutes, I have taken one more reading. Let us assume it is 51 degrees centigrade. After 20 minutes, I have collected one more reading. Maybe it is 43 degrees centigrade. Now, finally, after 30 minutes, I took the final reading. It is 32 degrees centigrade. Yes, I'm doing experiment on the particular object, some object. Initially, the temperature of an object is theta, and let us assume the temperature of the surroundings is by theta naught. and here I have a sample. Here I have collected few samples. Initially, I took one reading, it is 65. After 10 minutes, I have collected one more reading, it is 51 degrees centigrade. And slowly, I have observed the temperature of a body is decreasing, and I have collected 4 samples. Now the question is, what is the temperature of an object after 17 minutes? If you see the table, the 17 minutes is not available. Or one more question, at what time Ma Lakshmi Tulasi, what is this? At what time the temperature reaches some 46 degrees? And in the first question, I'm expecting the temperature after 17 minutes. In the second question, I'm expecting the time when the temperature reaches 46 degrees centigrade. If you want to answer these questions, yeah, certainly we are going to depend on Newton's law of cooling. Okay. Ma'am, it's not possible to write with this.
ఓకే సార్, ఒకసారి ఉన్నాను సార్, చెప్తాను సార్. సోమేష్ సార్.
ఎస్ మ్యామ్.
సార్ ఏంటి అంటే సార్ ఏదో ప్రాబ్లం అంటున్నారు, ఒకసారి చూడండి సార్.
సార్
రాశారు సార్ వీళ్ళు లక్ష్మీ తులసి, ఇంకా ఫ్యూ పీపుల్ ఆర్.
ఐఎమ్ జస్ట్ చేంజింగ్ ద సెట్టింగ్ సార్, జస్ట్ గివ్ మీ ఎ మినిట్.
Okay sir, it's very best. Don't give the power to admin power or
Sir,
ma'am.
sir, I'm a student, sir. Once explain this topic, sir.
Newton's law of cooling, huh?
Yes, sir.
Yes, I'll explain. Just now I started. Once again, I'm going to revise. I have no problem, but I have to free from these lines. This was drawn by one student. That is why I'm not able to write here.
Okay, sir.
It's one of your college mate try to disturb.
అమ్మా, ఎవరికైతే అవసరం లేదో లీవ్ ఇట్ అమ్మా, వదిలేండి, మీరు వెళ్ళిపోండి మీటింగ్ లోంచి.
Those who are not required, just you may leave. ఇబ్బంది ఏముంది? But disturb చేయొద్దు నాన్న. We are in Hyderabad. Because here my motivation is, my intention is to transform the knowledge. Backlog students అనేసరికి చెప్పాలి అనే ఇంటెన్షన్ తో వచ్చాను నేను ఫస్ట్.
Sir, can you please try now?
So actually, if you remove these lines, these curved lines, it is easy to write. It is easy to explain for you. They are disturbing a lot, sir. It was drawn by one student in the middle. Shall I rejoin, sir? Sir, good evening. Can you please give me as admin power to change my screen?
Yes, sir. You are co-host now.
Yes, sir. Yes, sir. Okay, I think I'm audible, right?
Yes, sir.
And you are able to see my screen also.
Yes, sir.
Okay. Yes, the students who have joined a few minutes back, I have started the concept Newton's law of cooling. Here, I consider one object here, what you are observing here in the figure. And I denoted the temperature of an object by theta and the temperature of an object by theta naught. The temperature of the surroundings is by theta naught. Okay. And here, let us assume that the temperature of an object is decreasing. Here, when the temperature of an object is decreasing, I have collected few samples. Initially, at T equal to 0, I collected one reading. It is 65 degrees centigrade. After 10 minutes, I have collected one more reading from that object. This is the object. And where the temperature of an object is decreasing. And we have denoted the temperature of an object by theta and the temperature of the surroundings is by theta naught. And after 20 minutes, I have another reading. After 30 minutes, I collect one more reading. Totally, I collected the 4 readings here. Now the question is, what is the temperature of an object after 17 minutes? If you see, 17 is not available in the table in my readings. And at what time the temperature reaches 46 degrees centigrade? Here, I have 2 questions. After a certain time, what is the temperature? At what time the temperature reaches? Okay, now some 46 degrees centigrade. If you want to answer these questions, yes, we are going to depend on Newton's law of cooling. Okay, so once again here I draw the object. Here the temperature of an object is theta and the temperature of the surroundings is theta naught. Okay, according to Newton's law of cooling, the rate of change of temperature of an object yes. The rate of change of temperature of an object is directly proportional to the difference between the temperature of an object and its surroundings. Okay. Dear students, so when we have a problem, a real life problem, always we are interested to find its solution. Yes, the ultimate thing is, what is the solution of a real life problem? If you want to find the solution of a problem, you have to connect this with proper mathematics. Yes. Or what is the area? So the problem is going to convert in terms of a system of equations that can be solved by matrices. Or if the problem is converted into a differential equations, yes, you know, by applying certain methods, homogeneous, non-homogeneous, exact, non-exact. If it is a higher order differential equations, finding the complementary and particular integrals, you may find the solutions. And when you are going to find the solutions to the real world problem, we have to convert the problem into certain equations. We have to convert the problem into a mathematical equation. But based on the scenario of the problem, you have to model it. If it is converted to matrices, okay, you may solve by using Gauss elimination or Gauss Jordan. Yes, your wish, or Gauss Seidel. Or if it is converted to a differential equations, apply several concepts of methods of differential equations. Or otherwise, sometimes we apply Laplace transform, Fourier series, Fourier transforms, like that. Here, a problem is here. Here, we have a problem. What is the problem? The temperature of an object is decreasing. And we are going to find the temperature at some particular points, and we are also finding the temperature at some time. Now, here, yes. Now I'm going to formulate. And formulate means what is the proper mathematics equation regarding this? Okay. Now, coming to this, rate of change. Yes. Rate of change is nothing but d by dt. Change with respect to time. Temperature of an object. What is the temperature of an object? Theta. Yes, here I was already clearly mentioned. The temperature of an object is theta. Is directly proportional to the difference between the temperature of an object and its surroundings. Yes, this is the corresponding mathematics equation related to the above definition. Yes, by using the above definition, I converted this into a first order differential equation. Here, when we remove the proportionality, certainly you will get a constant. But here I will take the negative constant because the temperature of an object is decreasing. Here the temperature of an object is not increasing. Here the temperature of an object is decreasing. That is why I'm taking the negative constant. Now I'm going to solve by this using the variable separable method, separating the variables. Yes, when you integrate both sides, theta naught is a constant. That is the surrounding temperature. This gives log integration of 1 by theta, log theta, right, is nothing but minus kT plus C. Yeah, by using this equation, we are going to find the temperature after certain time, or at what time the temperature reaches to some amount. Now it is by using this principle, we are going to answer to the questions very easily. Here we are going to solve one problem. Okay. A body is, dear students, I'm starting the problems. Okay, now by using the formula log theta minus theta naught equal to minus kT plus C. And the most important thing, all of you remember, here I already said logarithms are two types. Logarithms are two types. One is base 10 and another one is base E. Here we are using the base E, exponential. Okay, now this is called natural logarithm or Neperian logarithm. A body is originally a body is originally 80 degrees centigrade and cools down to 60 degrees centigrade in 20 minutes. If the temperature of the air is 40 degrees centigrade, that means air is the surrounding. Air is the surrounding. You must notice here. Okay, na? Then in every question, the surrounding temperature will be mentioned. Don't worry. But in case if the surrounding temperature is not given, then take the normal room temperature, 27 degrees centigrade. Your wish. In the given question, if the surrounding temperature is not given, then you have a freedom to select normal room temperature. Okay. Now, yes, before I'm going to solve, I'm going to read the question. A body is originally 80 degrees centigrade. Okay. Originally, initially, starting. Whenever you observe the words originally, starting, always take the time 0. Until your investigation started now only. When you have started the investigation on the present problem, your time starts now. That is why I'm taking time as 0 and it is 80. A body is originally 80 degrees centigrade and cools down to 60 degrees centigrade in 20 minutes. Okay. If the temperature of the air, let us denote the temperature of the surroundings by theta naught. Then find the temperature of a body after 40 minutes. After 40 minutes. Okay. Yes. According to Newton's law of cooling. Can anyone say what is the formula, dear students?
Minus KT plus C, sir.
Right. Log theta minus theta naught equal to minus KT plus C. Here I will tell you few important things. Initially, we substitute this data. That gives C value. That gives C value. Later, I substitute this data that gives K value, and finally, I will get answer. This is the sequence of the solution. First, we determine C, later we determine K, and finally, yes, certainly the answer will come. Okay, right. This is the formula, log theta minus theta naught equal to minus KT plus C. But the most important thing is here the logarithm base E, natural logarithm. Okay, now, what is the initial data?
0,
What is the temperature?
80, sir.
degrees centigrade. Very good. Okay. Can you please substitute here? Log 80 minus, what is theta naught? What is the temperature of the surroundings?
40, sir.
40. Very good. And time is 0. Now, T equal to log 40. C equal to log 40. I already explained, I already revealed. Initially, we get the C value. Yes, C is obtained. Now, we must update the equation 1. Substitute C equal to log 40 in equation 1. Yes, the equation 1 now transform to, or it becomes minus KT plus log 40. Now this is equation 2. Now just concentrate on equation 2 only. What is the second reading?
Time
Can anyone-
20, sir. Degree temperature 60 degrees.
Good. Theta naught. Always, yes, this is constant. This will not vary. Okay, surrounding temperature. Log 60 minus 40 equal to minus K into 20 plus log 40. Log 20 equal to log 60 minus 40, log 20 equal to minus 20K plus log 40. Now, okay. So send 20K to left side and log 20 to right side. Therefore, log 20K equal to log 40 minus log 20. We have a formula. Log A minus log B, log A by B. Log A by B, 20K equal to log 40 by 20, log 2. K equal to 1 by 20 log 2. Yes. Yeah. We have is K value. Now substitute K value in which equation?
2, sir.
2. Tell me, if you substitute K value in equation 2,
40.
substitute K value. Sorry, wait. Substitute K value in equation 2. Log theta minus theta naught equal to
Minus 1 by 20
okay.
log 2 plus log 40, sir.
I think into T, you are missing T plus log 40. Okay,
Okay, sir.
fine. Now, almost we came to the end of the solution. This is equation 3. And what we are expecting here in the problem, what we are expecting?
Temperature 40 దగ్గర degrees ఎంత అనేది find out చేయాలి.
Okay. Right. Substitute log theta. Theta naught is surrounding temperature. That is 40. That is 40 equal to minus 1 by 20 into log 2 into replace time by 40 plus log 40. Okay. Here clearly we are able to cancel 20 to log theta minus 40 equal to minus 2 log 2 plus log 40. And we have a formula. What is m log a? Log a power m. Log theta minus 40 equal to log theta minus 40 equal to 2 power minus 2 can be written as 1 by 2 square. And there is a simple formula. What is log A plus log B? Log AB.
A by B.
Log A plus log B. Log AB. Okay. Log 40 by 4. Log 40 by 4. Log 10. Log 10. Now, can you remove the logarithm both sides? Remove the logarithm both sides. Theta minus 40 equal to 10. That implies theta equal to how much? 50 degree centigrade. Finally, what is the answer? Theta is how much?
50 degrees.
50 degrees centigrade. Yeah, and here the most important thing is here we have no work with the scientific calculator, but most of the problems in Newton's law of cooling, we use, we have a, certainly we depend on the our scientific calculator. Now I'm going to solve one more problem in the same concept. Here we use the scientific calculator, I will tell you. Okay. Now, see. Here, so most of the people are interested to know while solving the problems. At least some people are curious about where they are going to use. In the beginning of my presentation today, I was clearly explained the concept is used in metallurgy when the temperature of the metals are decreasing, and also in the forensic science. In the forensic science also, before the CBI, CID or the police people, if there is a murder, certainly the police people are going to start the investigation. But before they start the investigation, the forensic science people will start doing their, start collecting the samples. They are going to collect the blood samples, fingerprints, footprints. At the same time, they also estimate the time of death, because when a human being will die, the temperature of the body will reduce. Based on this concept, they're going to convert, they're going to use the Newton's law of cooling. They will also say the time of death when a human being will die, whether it is a natural death or whether it is a murder or a suicide. Okay, now it is easy to estimate the time of death by using the Newton's law of cooling. If the temperature of an object is 100 degrees centigrade to 70 degrees centigrade in 15 minutes. When the temperature will be 40 degrees centigrade, if the temperature of the air is here, may I know what are the here? What is the surrounding here?
30 degrees Celsius.
Air, 30 degrees centigrade. Very good. Yes. Before we're going to solve the problem, let's have the readings. It is very important to prepare the table. Okay. The temperature of an object is changing from 100 to 70. In how many minutes?
15 minutes, sir.
Initially, the temperature is 100. After 15 minutes, what is the temperature? 70. Yes. And within 15 minutes, the temperature drops to 100 to 70. When the temperature will be 40 degrees centigrade. Okay. Of course. Have you noticed the difference between the first question and the second question? See the table. This is the table for the first question. And this is the table for the second question. Can anyone identify the difference here? What we are expecting? In the first question, what is given? Time. We are estimating the temperature.
Degrees.
Degrees. Yes, good. You are excellent. Here in the present problem,
టెంపరేచర్ ఇచ్చారు, టైం ఫైండ్ అవుట్ చేయమన్నారు సార్.
right. What is the Newton's law of cooling formula?
Log theta minus theta naught equal to minus KT plus C, sir.
Equation 1. Yes. This reading and this data will give you which value? C value. It gives K value. It gives answer. Now, get ready to substitute the initial reading. When time 0, what is the temperature? 100. log 100 minus 30 minus k into 0 plus c. Therefore, c value is, what is the c value?
Log 70 degrees, sir.
70. Substitute c value in 1. Update the equation 1. It becomes log theta minus theta naught equal to minus kt plus log 70. Now this is the updated equation. Okay. Next, substitute the second reading. When time is 15, the temperature reduces to 70. I'm going to substitute this data. Log 70 theta naught. How much? What is the theta naught? 30. Minus k into 15 plus log 40 equal to minus 15k plus log 70. Can you say, can you interchange these two, 15k and log 40, or sending minus 15k to left side and send log 40 to right side? Tell me, what is the new equation? What is the next equation?
15k equals to log 70 minus log 40, sir.
Fine. Log A minus log B. Log A minus log B is nothing but log A by B. Yes, can you simplify this? Log 70 minus log 40?
Log 30.
Not log 30,
70
Nana.
by
70 by 40.
40.
This is the formula. Log A minus log B. Log 3 minus log 2, log 3 by 2. Okay. 15k equal to log 7 by 4. K equal to 1 by 15 log 7 by 4. Yes, C value came. Substitute K value in equation 2. Yeah, this is the equation. Present equation is 2. After substituting C value, equation 1 become equation 2. Now, we are going to substitute K value here. After substituting K value, it become equation 3. Okay. Now, K equal to 1 by 15 log 7 by 4. Substitute K value here in equation 2. Log theta minus theta naught equal to minus kt. Minus kt. What is K? Minus 1 by 15 log 7 by 4 t plus log 70. Okay. Equation 2 updated. And we are calling with equation 3. And what we are expecting from this question, that is very important. We came to the end of this problem. At what time the temperature reaches 40 degrees centigrade? Anyhow, surroundings 30. That is common in all the equations that we are going to substitute. Log, replace theta with 40. Here theta with 40 and theta naught surrounding temperature log T. We are estimating the time log 10 equal to minus 1 by 15 log 7 by 40 plus log 70. Okay. Send this term to left side and send this term to right side. 1 by 15 log 7 by 4 t equal to log 70 minus log 10. 1 by 15 log 7 by 4 t equal to log a minus log b. Once again, log a by
Log
b.
A by B.
Right, good. Okay. Log 70 by 10, log 7. Now, sending this 15 to left side. 15 log 7, and the last step, send log 7 by 4 to right side. Log 7 by 4. Dear students, when you have a scientific calculator, you have two functions, Amma. I think in the third row, the last two options are log and one is, sorry, and one is ln. This is important. Yes. ln is nothing but log base e, natural logarithm. Okay. The scientific calculator. ln means natural log. Log base e. This is log base 10. But here we are using, in this Newton's law, we are using natural logarithm. That is logarithm base e. And t equal to 15. This logarithm log 7. Here the base is e, not 10. Okay. Base 10 is nothing but common logarithm that we are not using here, because in the beginning I explained this rate of change of temperature is proportional to the exponential decay. Log 7 by 4, base is e. Just I'm adding the base e here. That's it. And a few seconds back, I explained when you are observing base e, that is natural logarithm. Dear students, which logarithm?
Natural logarithm, sir.
That is denoted by ln. That is denoted by ln. Yes. If you have a scientific calculator, just calculate and tell me the value. 15 into ln 7 by 4. If you see your scientific calc, in the third row, maybe the last option is ln. Using ln, if you calculate, that gives you the time. I'll give you 1 minute time. First of all, do you have scientific calc at right now with you?
మరి రెస్పాండ్ అవ్వండి. క్యాలిక్యులేటర్ ఉందా ఎవరి దగ్గరైనా?
If you have, I will wait. Otherwise, there is no use. I will write the answer. Don't worry. You may calculate later.
No, sir.
Okay. Tell me. Do it later when you simplify. Yes. Okay. It will give you 52.15 minutes. Approximately. Always put approximate. That's it. Okay. Coming to law of natural growth and decay. Natural growth and decay. Here we have a problems on the three concepts. A simple question from my side. When time increases, what about the population? Will it increase or decreases? according to the time. Yes, dear students. If you compare the today's population in India and the tomorrow's population, will it increase or decrease?
Increase, sir.
Increase, sir.
Yes. Yes. Virus or bacterial growth. Once again, when time increases, the development of
Increase.
yes, bacteria and virus increase.
Decrease, sir.
Certainly. But first two are related to growth. The third one, radioactive material. Whether it is uranium, whether it is thorium, whether it is plutonium. When time increases, plus means increases. Instead of writing increases, I am reusing that. When time increases, the amount of radioactive material, yes,
Decreases.
tell me, it's
Decreases, sir.
Decreases, sir.
decreases. Okay. Are you observing the PPT? This PowerPoint presentation, ma'am?
No, sir. Board only.
Now?
Yes,
Yes,
sir.
sir.
Right. Okay. If you see the problem related to the bacteria and virus, when time increases, the number of bacteria will certainly increase. The number of virus will also increase. Coming to the population, yes, day by day the world's population is increasing. The population, when comparing to time, the population will increase, the bacteria will increase. But coming to the radioactive decay, yes, when the nucleus is, from the nucleus, when the protons, when alpha, you know that in the nucleus, along with the protons and neutrons, there are several particles, alpha, beta, and gamma also. When the nucleus is releasing these alpha, beta, and gamma particle, certainly the weight of the radioactive material will decrease. This comes under the natural decay. When alpha, beta, and gamma particles are coming out or from the nucleus, certainly the amount of the radioactive material will decrease. And now this board.
Yes, sir.
Right. Okay. Okay. Now the question is, yes, dear students, we know how much we have suffered from the corona 3-4 years back. In fact, myself, I was affected twice in that pandemic time. Yes, here assume that in the day one, the corona cases are one. Yeah, we have observed one case was registered in Delhi. After 3 days, suppose the cases are increased to 5. After 15 days, if the cases are increases to 120, and we know after 1 month how many cases increased, after 2 months, after 6 months, how the corona increased, how we have affected, and that leads to lockdown. Okay, now that leads to online classes. In fact, we have also trained to explain the classes in the online mode because of the pandemic time only. That is a new system that we have. Initially, we have no enough training, proper methodology how to teach in the online mode, because in the pandemic time only, you know, you have listened the classes in online. See here, see, suppose we have observed these cases. Initially, we have observed one case in India. After
Sir, your
3
voice is breaking.
days, the cases, the corona cases are increased to 5. Voice is not clear. Now, ma'am? Now?
Yes,
Now
sir.
it's clear, sir.
Clear, sir.
Okay. Now, after 30 days, how many cases will be present in the India? But we have observed the cases up to 15 days. First day 1, after 3 days 5, after 15 days 120. After 30 days, what are the total number of cases? How to answer? After observing the cases at 15 day, I want to predict. This is called the prediction. At 16th day, I have to predict. Or after 2 months, how many cases will increase? If they can really predict, then we are going to arrange the number of oxygen cylinders, or we are going to supply, the government has to supply the beds, the government has to supply the medicines or vaccine, or if they want to do certain investigation, they have to know after 6 months, how many cases will register. Yes, this comes under the law of natural growth. If you apply the formula, yes, of course, I will tell you, we will derive, dear students, we will derive. This is the formula, n equal to c into e power kt. Using this formula, not only after 30 days, after 45 days, after 50 days, after 6 months, it is easy to estimate, yes, the growth of corona or any virus or any bacteria using this. Okay, and let us assume that at present I have 1 gram of uranium in my hand. I have 1 gram of uranium in 2024. After 3000 years, after 3000 years, this uranium become 0.5 gram. Its half-life period. This is called its half-life period. Under the time taken, exactly the material become half. We know that the uranium half-life period is 3000 years. Half-life. Half-life period is 3000 years. That means, okay, now 3000 means 2024 plus 3000, 5024. The 1 gram will become 0.5 gram. Now the question is, in the year 3020, how much uranium left? This is the question. Yes, I want to answer it. If you want to answer this, yes, you may apply the Newton's law of cooling. You may apply the Newton's law of cooling. Okay, suppose initially the population are at present in 2024, the population of Australia or US 34 crores, or in 2025 it increased to some 35.3 crores. And after 2026, what is the population? If you want to answer all these questions, okay, if you want to answer all these questions, we use law of natural growth and decay. What is the law of natural growth and decay? Yeah, the rate of change of substance at any time is directly proportional to the amount of substance available at that time. The rate of change of substance at any time is directly proportional to the amount of substance available at that time. See here, in the beginning, we have one case. From the second day, the increment is proportional to 1. After 3 days, the number of corona cases increased to 5. But later from 4th day onwards, the increment is proportional to 5. If you see, after 15 days, the cases are increased to 120. After 16th day, yes, the strength will increase in a large, because after 16th day, the population is proportional to 120. And the 120 virus can generate more number of. And from the 16th day, the development of the corona is proportional to the at present what it has. Now, if you are going to formulate this, can anyone say what is the rate of change means? How we represent rate of change in terms of differential equation? D by dt. Are you able to hear me?
Yes, sir.
Okay. Rate of change of substance. The rate of change of substance at any time is directly proportional to the amount of substance available at the time. Let X is the amount of substance. It may be a population, number of population, or number of bacteria, or amount of radioactive material. I'm representing by X. Yes, the rate of change of d by dt substance is directly proportional to the amount of substance available at that time. Okay, right. Remove the proportionality. If you remove the proportionality, what you will get? Constant. Dear all, that population will increase according to the time. We take plus k. Virus will increase according to the time. Take plus k. But for the radioactive material, it will decrease. We have to take minus k. Okay. Now, solving by variable separable method. Solving by variable separable method. Send x to left side and send dt to right side. Integrate both sides. Here I'm applying variable separable method. 1 by x dx equal to integration of 1 by x dx equal to k dt. Integration of 1 by x. Yes, what is integration of 1 by x? Log x equal to kt plus log c. Instead of c, I am taking a log c, because here this is once again, this growth is, it is proportional to the exponential growth.
Yes, sir.
Okay, log x minus log c equal to kt. Log x by c equal to kt. Remove the logarithm. X by c equal to e power kt. X equal to c into e power kt. We use this formula for population problem or virus or bacterial. But if it is a radioactive material, we'll take minus k, because the amount of the radioactive material will reduce when the time increases. Coming to the problems, the number of bacteria N was initially 100 and increased to 332 in 1 hour. Then what is the number of bacteria after 1.5 hours. Dear students, I was observed the previous papers. There is one question from this Newton's law of cooling or law of natural growth and decay. So that is why I treated this is important. Yes. The number of bacteria was initially 100. Yes. When time 0, bacteria was 100. After 1 hour, it increased to 332. So after 1.5 hours, what is the number of bacteria? We know that the formula is N equal to C into e power kT. So once again, the solution as usual. First, we are going to substitute this data that gives C value and this gives K value. And finally, we obtain the answer here. Are you ready to substitute the data? Tell me, what is the first reading? Those are listening the class. What is the first reading, Amma? When time 0, are you in active mode?
మరి రెస్పాండ్ అవ్వండి అమ్మా.
Otherwise, it's going to be simple demonstration. All of you, you are not watching a movie here. You are learning. So we'll close the concept by I will explain two. They are very easy problems. I'll explain two, 3 problems here only. Then we'll stop the class. But at least you respond. Initially, the number of bacteria was 100. 100 equal to C into yes. E power 0 is 1. Therefore, C is 100. Okay. Substitute C equal to 100 in equation 1. Once you update the equation 1 with C value, we call this equation 2. And get ready to substitute the next reading. After 1 hour, the bacteria increased to 332. Yes. I'm substituting the data once again to determine K value. I substituted time 1 hour, and N is 332. Here you may notice one thing. You may convert the time in minutes also. Your wish. 332 by 100 equal to e power k. 332 by 100 is 3.32. That implies k equal to log base e 3.32. I already explained clearly. This is ln natural logarithm. Ln 3.32 is 1.199. Now substitute k value. Substitute k in equation 2. That gives this is equation 3. And finally, we are going to determine the bacteria after 1.5 hours. That means 1.5. 1.5 hour means 1.5. Substitute t equal to 1.5. That gives approximately some 600. 604 or 605. Yes. I'm going to the next one. The bacteria development is exponentially increasing from 200 to 500 grams in the period from 6 a.m. to 9 a.m. how many grams will be present at noon? Noon means afternoon. Okay. Don't take t equal to 6. Here, your observation starts at 6 a.m. That is 0. You have started investigating the problem at 6 a.m. Your observation starts in the morning 6 a.m. That is your initial reading. Yes. Initially at 6 a.m., the number of bacteria is 200 grams. After 9 a.m., what is the duration between 6 a.m. to 9 a.m.? 3 hours. It decreases to 500 grams. 12 p.m. means noon. And after 6 hours, what is the number of bacteria? Then we must take the time 0, 3 hours, 6 hours. Because the duration between 6 to 9 a.m. is 3 hours, 6 to 12 p.m. is 6 hours. So once again, I use the formula n equal to C into e power kt. Yes, we know that initially the number of bacteria was 200. 200 equal to, yes, I'm substituting time 0 in the equation 1. Initially, we know that the number of bacteria was 200. E power 0 is 1, therefore C is 200. Substitute C equal to 200 in 1, that gives n equal to 200 into e power kt. I already explained several times. This gives C value, it gives K value, and finally we get the answer. And here, after 3 hours, wait a second, it was not clear. After 3 hours, the bacteria increased to 500 grams. Okay, fine. Get ready to substitute this data to determine K value. Sending 500 to, moving 500 to left side. 500 by 200 equal to e power 3k. E power 3k equal to 5 by 2. E power 3k equal to 2.5. 3k equal to log 2.5 base e. K equal to 1 by 3 log 2.5 base e. This value is 1 by 3 ln. If you have a calci, tell me. Otherwise, I will calculate here. .305. Substitute now K value into e power. It gives equation 3 and substitute t equal to 6 hours to determine the bacteria after 6 hours. And that means at 12 p.m. in the afternoon session. 6, that gives approximately 1250. So in this way, we're going to find whether it is a bacteria, or whether it is a population, or whether it is a radioactive decay problems by using the relation n equal to C into e power kt. And dear students, notice that this formula is same for population and in bacteria virus problems. Use plus K, but coming to the radioactive material, take minus K, because that is a reverse case. Okay, in the beginning we discussed, when the time increases, the amount of the radioactive material will decrease. Okay, that is why this is x equal to c into e power kt. It is also x equal to c into e power kt, but this is x equal to c into e power minus kt. That is the most important thing here. Ma'am, is it enough for them? Shall I stop or continue? Shall I explain one more?
సార్ ఒకసారి క్వశ్చన్ పేపర్స్ లో ఈ టాపిక్ రిలేటెడ్ క్వశ్చన్స్ ఒకసారి చూడండి.
Madam, R23 regulation, ma'am.
ఎస్ సార్ మార్నింగ్ ఐ విల్ పోస్ట్.
Ma'am, there is a problem, ma'am, here. Okay. Ma'am,
Yes.
we have,
Yes,
dear
sir.
students, there is a question. Initially, the bacteria, bacteria population is 10,000. After 5 days, 20,000. Initially, the bacteria, wait a second, it's 10,000. After 15 days. Okay, wait, after 5 days, this is second one is 5 days. We have to use the same, like the first problem, use n equal to c for kt, substitute this, you will get c and you will get k and you will get answer. It is like the first problem model. Instead of 103.32, here we have just large readings. And moreover, are you able to see my screen, ma'am?
Yes, sir.
Yes, okay.
Just discuss.
One more question, ma'am, here. I hope you are observing the question paper here.
Yes, sir.
This 3B already covered, madam, in my explanation. This 3B.
Okay.
3B in Newton's law of cooling is the first problem.
Okay, sir.
This is a body is originally 80 degrees centigrade and cools down to 60 degrees centigrade in it was covered. And 3A, I'm concentrating on 3A. A bacterial culture growing exponentially 100 to 400 grams in 10 hours. How much was presented? Same model. This is also same model. 100 to 400 grams in 10 hours. Initially 100. After 10 hours, 400. I think the question is after 3 hours. Use the formula n equal to c power kt. If you substitute the data, dear students, that gives c value. And if you substitute this, it gave k value. Sorry, this is a question, right? Substitute this, it gives k value and it gives answer. Madam, you have covered all the problems in this model, ma'am.
Okay, sir. Okay, sir.
They're
Fine,
able
sir.
to answer. A body kept in temperature with 25, 140 to 80 in 20 minutes. When the body cools down to 35.
ఓకే సార్ ఫ్రమ్ ఫస్ట్ యూనిట్ సార్ ఒకసారి అబ్జర్వ్ చేయండి ఫస్ట్ 2 క్వశ్చన్స్ అంటే 2A and 2B సార్ సో
Yes, ma'am. That will also, I will also cover them in the next class.
ఓకే సార్ ఓకే సార్
Madam, tomorrow, I think whenever you will provide the next session, I will start the
Okay.
linear and non-linear, Bernoulli and linear and Bernoulli.
ఓకే సార్ ఓకే
Linear,
అండ్
Bernoulli.
ప్రాబ్లమ్స్ అండ్ ఎగ్జాక్ట్ డిఫరెన్షియల్ ఈక్వేషన్స్ ఆల్సో
Sure, ma'am.
ఓకే సార్
Certainly linear, non-linear, exact in 2 hours.
ఎస్ సార్
No doubt, ma'am. Certainly I will cover them. In the next
Okay.
session will be linear, non-linear, exact. If we discuss them, that will be the okay, na, that will be the end of the first
Okay.
unit.
ఓకే
Right, ma'am. Thank you, ma'am. Right.
Thank
Shall we
you.
leave?
ఎస్ సార్
Ma'am, last students విన్నరో లాస్ట్ సెషన్ లో ఎంతమంది విన్నారో నాకైతే ఉన్నారా మేడం? ఓకే, స్టార్టింగ్ న్యూటన్స్ లా కొంచెం విన్నారు. అవును, కొంచెం ఆఫ్లైన్ కి ఆన్లైన్ కి కొద్దిగా తేడా ఉంటుంది మేడం. తేడా యూజ్ చేసుకొచ్చి ఇప్పుడు కూడా నేను మేడం ప్రజెంటేషన్ మేడం నాకు సంబంధించి నేనేం డిసప్పాయింట్ చేయలేదు వాళ్ళకి. థ్యాంక్ యూ మేడం. 100% పీడిఎఫ్ చేస్తాను మేడం. స్టార్టింగ్ కూడా మేడం కొద్దిగా డిస్టర్బెన్స్ అయింది, కానీ పీపీటీ నేను మంచిగానే ప్రిపేర్ చేస్తాను వాళ్ళ కోసం నేను యాక్చువల్గా. థ్యాంక్ యూ మ్యామ్. రైట్ మ్యామ్. చేస్తాను మేడం, ఎంత వీలైతే అంత కవర్ చేస్తాను. రైట్ మ్యామ్. రైట్.
సార్ సోమేష్ సార్.
Yes, madam.
సార్ మీటింగ్ ఎండ్ అయిపోయింది సార్. సార్ అయిపోయింది
Okay,
సెషన్.
ma'am. Class close. Yes.
ఓకే సార్.